Okay, so I am recording, okay? Whoever told me the last recording didn't match, who was that? There was something missing. Okay. So was it 5.4? Was it last time's?
Yes.
Yes. So it's because I was having memory issues, but I've got it all figured out. So anyway, I'm recording, long story short. So a couple of questions. Is this section going to be on the quiz? Tell me that. It is. If I teach it before you take the quiz, it's always there, even if it's the period right before, okay? Did we highlight this section saying that it showed up on the midterm last semester? Yes. Yes? Okay, great. Okay, here we go. This is 5.5. I think you're going to be fine. Make sure you have your calculator on your desk. We're going to do lots of calculator work today, okay? Okay, find the remainder of long division, okay? So on the outside, you have an x minus 1. Now, we want to be really careful that we're not missing anything. So the x is raised to the first, and we have a constant, and we're good. What goes on the inside, guys, you have an exponent of 3, 2, 1, constant, so we're not missing anything. So I'm just going to fill those in. Okay, what do I multiply by x to get 3x to the third? That would be 3x squared. Then I distribute, and I get 3x to the third minus 3x to the second. Change my signs. First terms cancel. I get a negative 2x to the second, bring down the 3x. You guys, without a doubt, the biggest mistake that people make on long division, they don't change the signs. 100%. Biggest reason. What do I multiply by x to get a negative 2x to the second? It's a negative 2x. Distribute negative 2x to the second plus 2x. Change your signs. 2x squared to cancel. I get an x, bring down the 10. What do I multiply by x to get x? That would be a 1. Distribute, x minus 1. Change my signs. First terms cancel. I get a negative 9. They wanted the remainder, and I'm going to say it's a negative 9. That's how you write it. Okay? Now, look what they're doing. They took the denominator, set it equal to 0, and they got x equals 1. So now they're saying take that 1 and plug it into the original numerator, which is right there. Okay, so everybody go 3 times 1 to the third minus 5 times 1 to the second plus 3 times 1 minus 10. Just for time purposes, I'm just going to tell you, well, first of all, let me say this. All these things right here, didn't mean to scribble. This thing right here, 1 to the third, 1 to the second, 1 to the first, those are all 1. It's not going to change anything. So it's really just 3 minus 5 plus 3 minus 10. And when I plug that in, I get a negative 9. Okay? You guys, that's always going to happen. So if you set the bottom equal to 0, plug it back in, what you get is always going to be your remainder. Okay? It's called the remainder theorem. Okay, so look at this right here. When you're dividing by x minus c, if you set that equal to 0, you get x equals c. And then if you plug c in, then you get the remainder. Okay? Okay, the next one is, if x minus c is a factor, if you solve that for x, you would get x equals c. And then when you plug c in, the remainder is 0. So if anything's a factor, when you plug it in, you get a 0. You know it's a factor, okay? Okay, so example 2. Use the remainder theorem and the factor theorem to decide if this is a factor, okay? It's really pretty simple. Set the x plus 3 equal to 0, you get x equals negative 3. Now, go negative 4, in parentheses, negative 3 to the third, plus 5 times negative 3 to the second, plus 8. Okay, I really like storing numbers in instead of like inputting all those negative 3s. So I'm going to go negative 3, store, enter. And then I'm going to go negative 4, membar, enter, raise it to the third, plus 5, membar, enter, x squared, plus 8, enter, and I get 161. Okay, so is x plus 3 a factor, everybody? Yes or no? It's not. Tell me why the answer is no. Because the remainder is not 0. If I got a 0, the answer would be yes. Okay? Okay, let's do the next one. Take your x plus 2, set it equal to x equals negative 2. then go 3 parentheses negative 2 to the third, plus 6 parentheses negative 2 to the second, minus 15 times negative 2 minus 30, and when I plug that in, I get a 0. Okay, we could sit and plug it in. I'm just telling you we got a 0. So is it a factor, yes or no? Yes, it is. Okay, now I just want you to freeze and I just want you to listen for 2 seconds, okay? I'm going to try to only say this one time, but if you can understand, it's awesome. Okay, so look right here. The process that I'm about to go through, what it does is this. It takes something like this problem right here that is very, very difficult to factor. I mean, like if someone said to factor that, it's too big. So you start taking numbers, you start plugging them in, you find something that when you plug it in gives you a 0, then you know it's a solution. And like if I put in x equals 3, I know x minus 3 is a factor. So then what it does, you guys, is it takes this thing that is very difficult to factor and it starts helping me to factor it. That's the whole point of this whole thing, is solving something that is very difficult to factor. Who says, I understand what you're saying to me? Okay, great. Okay, so let's come back up here. And okay, now we're going to talk about synthetic division. So I haven't allowed you to do synthetic division up until this point. I've had a couple of people ask me. Now that I'm going to show you, we're going to do it like all period long, then you are allowed to do it at this point. Okay. Okay, so right here on the side of question 3, I want you to write 3x to the third plus 6x to the second minus 15x minus 30. Put that in parentheses and divide it by x plus 2. So instead of doing long division, you can do synthetic division. For a minute, it might be a little confusing. Just stick with it. It's like 5 times faster. I'm not exaggerating. It's like 5 times faster than long division, okay? And it's easier. So if you set x plus 2 equal to 0, you get x equals negative 2. So you take that negative 2, and that's the number that goes in that little space right there, okay? Now look at the exponents, guys. We have 3, 2, 1, and constant, so I'm not missing anything. So see how the coefficients are 3, 6, negative 15, and negative 30? That's what goes right there. Okay. Okay, now watch what you do. See this first number 3? It always just comes straight down. And then you take the 3 and you multiply it by that negative 2. That gives you a negative 6. And then you combine 6 and negative 6. I don't say add and I don't say subtract because sometimes it's add and sometimes it's subtract. So you just combine those. 6 minus 6 is 0. 0 times negative 2 is 0. A 0 and a negative 15 is a negative 15. A negative 15 times a negative 2 is a positive 30, and I have no remainder. Since I got no remainder, look what I know. I know that I have a factor of x plus 2. I know that I have a solution of x equals, everybody tell me. If I take x plus 2 and set it equal to 0, everybody, what do I get? Negative 2. So I know I have a solution of negative 2. Okay, I want to show you one more thing. Do you see how this exponent right here is a 3? I did synthetic division one time. So then if I go 3 minus 1, I get a 2. So this 3 right here is an x to the second. So what I'm left with is 3x to the second. I could put plus 0x, but that doesn't do me any good. And then I've got minus 15. So that's the result of the division. If I had done long division, that would be exactly what was at the top. Okay, we'll do more, so don't worry. Okay, question 4. Is x plus 2 a factor? Okay, find all the real zeros. Well, take x plus 2, set it equal to 0, and you get a negative 2. Now take that negative 2 and put it up in that corner. Now, you guys, I don't have an x to the third. So you have to go 1x to the fourth, 0x to the third, minus 7x to the second, and negative 6x. And guys, you also need a constant. So fill in a 0 at the end. Okay? Now, bring your 1 straight down. 1 times negative 2 is a negative 2. 0 and negative 2 is a negative 2. A negative 2 times a negative 2 is a positive 4. A negative 7 and a positive 4 is a negative 3. A negative 3 times a negative 2 is a positive 6. 6 minus 6 is a 0. 0 times negative 2 is a 0. And I have no remainder. So now you tell me, is x plus 2 a factor, yes or no? Yes. So the first thing you're going to answer is yes. That's the first question. Okay. Find all of the real zeros. Okay. So look, guys, this biggest exponent right here was a 4. I did synthetic division 1 time. 4 minus 1 is 3. So that tells me that is an x to the third. So now I have a 1x to the third minus 2x to the second minus 3x. I could put plus 0, but plus 0 doesn't do me any good, okay? And I'm trying to find the solutions, the zeros. So I'm just going to set it equal to 0 and then solve that. Someone tell me what you would do as a first step right there. Take out an x is exactly right. If you take out an x, you're left with x to the second minus 2x minus 3. Please don't forget your equals 0. And then you factor, so the x to the second goes to an x and an x. The 3 goes to a 3 and a 1. Signs are different. Biggest is the negative. Looks like that. Okay. Then this times this times this gives me 0. So I get x equals 0, negative 1, positive 3. Highlight my answer, and I'm done. And I'm wrong.
Oh,
What?
This is a 4th power, which means usually I'm going to have 4 solutions unless something is a solution twice. Let me finish. And I only have 3. So now tell me, what did I not do? The negative 2 is also a solution. Good. Okay. Everybody listen. Next time I see you, I'm going to give you a study schedule. Your study schedule is probably going to require that you study for this test, I would think at least 5 or 6 hours for this midterm, okay? But we're going to do a little bit every day, so it's not going to get all, it's not going to freak you out. When you're done taking this midterm, when you go through and you've done the last problem, it's so silly to turn it in and space out for 30 minutes because you finished early. You're going to check every single problem. Is this problem checkable? Yes or no? Can I check this?
Yes.
Yeah, I can check it so fast. I can check the whole problem. Even though I have 4 solutions to check, I could probably check this in 45 seconds. What do?
Nemvar, storage.
Plug them in. What should I get every time I plug them in? A 0. Good. And we will do that, just not right now. Okay, here we go. Question 5. Show that these are factors, okay? And then find all of the remaining factors. So everybody write factors. And then write x minus 2 and x plus 3. So those are both factors. Well, if those are both factors, then I have a solution. Those aren't zeros, but what are the zeros or the solutions? Tell me. If I said x minus 2 equal to 0, I get 2. And what's the other one? Negative 3. Okay. Now, it doesn't matter which one I do first. I'll just do the 2 first because it's listed first. So everybody write your 2 down. And then look at what's going to go across the top. Stop and pause and look at your exponents. 4, 3, 2, 1, constant. I'm not missing anything. So no zeros. So I've got 2, 7, negative 4, negative 27, negative 18. Okay, draw your line. Now I want everybody to freeze right here. Please don't write for just a second. This is big. If I'm doing this right, because it says show, what's going to happen when I'm done with that synthetic division? If I didn't make any mistakes? No remainder. Yes. So I better not get a remainder because x equals 2 really is a solution. They told me, right? Okay, so pull your 2 down. 2 times 2 is 4. 7 plus 4 is 11. 11 times 2 is 22. A negative 4 and a positive 22 is 18. 18 times 2 is 36. A negative 27 and a positive 36 is a 9. 9 times 2 is 18. I just showed that x equals 2 is a solution. And I'm feeling very confident, like I'm doing this correctly. X equals 2 is a solution, which means x minus 2 is a factor. Okay? Okay, now I have to do the negative 3. Don't start over. The point is, listen guys, we're taking that big monstrous thing and we're breaking it smaller, smaller, smaller into something that I can manage, because I can't manage an x to the 4th, it's too big. Okay, so write your negative 3 and we're going to stack it on top of it. It's called stacking. So pull the 2 down. 2 times negative 3 is a negative 6. What better happened while I'm doing this? At the end, what happens? No remainder again, right? 11 minus 6 is 5. 5 times negative 3 is a negative 15. And 18 and a negative 15 is 3. 3 times negative 3 is a negative 9. And I know I'm doing this right. That's the awesome thing about this lesson. You've got these little check marks throughout the lesson that you're like, okay, I know I'm doing this right. Yes?
Would it matter if you did the negative 3 first?
Doesn't matter. No, it'll just look different, but the 253 would be at the end. Okay? Okay, so guys, everybody watch. I have this exponent right here of 4. I did synthetic division twice. So that means that 2 is a squared. So everybody go 2x to the second plus 5x plus 3. Okay, that's what I'm left with. So I've broken that big guy down all the way down to that. Okay, I want to say something right now that I think is super important. So look right here. That's what I have left. You don't have to write this down. The other 2 factors were x minus 2 times x plus 3. So if I took the time to factor all those down, I would end up with that guy, or to multiply the whole thing out, I would end up with that guy right there. Who says I understand? Raise your hand. So it's helping me factor it, okay? Now, they said they just want the remaining factors, so I'm not going to include that in there. So you guys, if they want factors, should I set that equal to 0 or not set it equal to 0? Not. When do they want me to set it equal to 0? When I'm looking for, tell me. Solutions or zeros, yes. So we're not going to do that, and we're just going to keep factoring. So it's going to go to 2x and a plain x. The 3 is going to go to a 3 and a 1 like that. Signs are the same. They're both positive. Okay? So they say find the remaining real factors. So that is your answer. Okay? Now, we're not going to be done with this yet. Okay? Write down full factorization. So the full factorization would be the 2x plus 3 and the x plus 1. And what would go with it, everybody? The x minus 2 and the x plus 3. Okay? If they said find all zeros, everybody freeze for a sec. This is why I think math is tough. It's like, it's the same idea, it's the same thing, and they give you literally 4 words that mean the same thing. Like, why not just give me 1? That's confusing. So zeros is 1. What's another word? Solutions. What's another one? X-intercepts. Although you guys know intercepts would be written as an ordered pair, but it's still the same value, right? What's the last one? My period 2 could not answer this question either. I think secondary 3 and 2 and 1, they don't use this word very often. I know you've seen it. Starts with an R. Roots. Yeah, they're all the same thing. Okay? Except just be careful because intercepts, you know, have to be written as an ordered pair, right? So my solutions are x equals negative 3/2, negative 1, positive 2, negative 3. Could I verify those? Could I check those? Yes, plug them in, get zeros, right? Okay, here's what it's really going to look like. And I think you have about a 100% chance that this is going to be on your midterm. And I made your quiz look just like your midterm, so you have just about a 100% chance that this is going to be on your quiz. Okay? Yes?
I have a question.
Yes.
On example 4, what if you took out the x's before you did all the factors?
You could do that. You could do that. Yes. Yeah. Okay? All right. Right here. When you've done this before, who says we've done this before? Okay. Is this what your teacher would do? Your teacher would have you get your graphing calculator, put it into your calculator, look at the graph, find a nice x-intercept, like 0, 1, 2, 3, 4, 5 of the negatives, and that's where you'd start. That's how you'd find that initial number. Who says, yep, that's what we did? Anybody? Well, that's what you could do, okay? But Weber State won't let us have a graphing calculator. So I have no idea where to start because I can't look at the graph, right? So what are you going to do? Well, we're going to come up with a list of possibles, okay? So everybody write down the word constant right here. The constant is the number on the right-hand side of that equation that doesn't have any variables. So ours is a 3. And then the factors of the constant are the numbers that go into 3 evenly, which are 1 and 3. Okay, now write down the words leading coefficient. Do you see how the biggest exponent is a 3 right there, guys? And then do you see in front of that, the coefficient is a 2? So our leading coefficient is a 2. It's not always the first thing, it's the biggest exponent, the number from the biggest exponent. So the factors, the numbers that go into 2 are 1 and 2. So now what you do is you take the factors of the constant, which are 1 and 3, and you put them under the factors of the leading coefficient, which are 1 and 2. Now, that's not how you write them because that doesn't make sense, right? Written like that. So look what you do. You start with the 1, and you go 1 over 1 is 1. Then you stay with the 1, and you change the bottom. 1 over 2 is 1/2. Then I've got all the 1s, so now I change the top number 3. So it's 3 over 1 is a 3, and then 3 over 2 is 3 over 2. So it looks like we have 4 possibles. We actually have 8. And the reason we have 8 is because there's a plus or minus in front of it, okay? Very quick, true story. About 2.5, 3 years ago, Weber State used to grade my midterms, and they grade my final. So I didn't even get to grade your test. Somebody else did it. And I was anxiously awaiting the scores, and then they finally showed up on their site, and I looked, and there were like 9 people that got a 99%. And I was like, yes, I was so happy. And then as soon as I thought about it, I was like, oh my gosh, that's my fault. It's too coincidental. All of those 9 people would have gotten 100 if it wasn't for me. I knew it had to be my fault, and it was. And this was the problem. So this is how I had them write it. And Weber State said no credit for that because it looks like the plus or minus just applies to the 1. But the plus or minus applies to everything, so what do they want? Parentheses, yes. So be careful because I know from history that they will take your points off, okay? Yeah.
Could you write them each individually, like plus
Yeah.
or minus 1, plus or minus
Yeah,
1?
yeah. You totally could do that. No parentheses, yes.
Out of curiosity, so if you grade the midterms, how does Weber State know if you grade it how they want it?
They just trust me. You know, we go and learn, and they show us how they want us to, which it's really hard for me. But I'm not trying to boast about myself, but I'm a rule follower. And if something's right and wrong, I do the right thing. So it's hard because even though I don't sometimes agree with it, I have to do it, which is really strange, you know, when you're a teacher. So anyway, okay, find all the rationals. So here's what you do. Grab your calculator. And now I've got 8 numbers that might be solutions. So I have to find one that's a solution. How do I do that? Plug it in, and what should I get if it is a solution? I should get a 0. So everybody go 1 store, enter. And then go 2 membar, enter, raise it to the 3rd. Plus 3 membar, enter, x squared. Minus 8 membar, enter, plus 3, enter, and I got a 0. So I know 1 works. So right here, guys, I'm going to set myself up, and I'm going to say x equals 1. And then I'm going to set up my synthetic division. So I'm going to put a 1. And then my exponents are 3, 2, 1 constant. So I'm going to go 2, 3, negative 8, positive 3. Draw the line. 2 comes down. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 8 and a positive 5 is a negative 3. 1 times negative 3 is a negative 3. And right that second, I know I'm doing it right. Okay? Listen what happens. People end up getting a remainder they throw out the remainder, and then they start dealing with what's right there. If you get a remainder, stop, because you're wasting your time if you keep going. Something is wrong. Who says, I understand what you just said? Okay, great.
So there'll never be a remainder.
If it's a factor, no, it will never be a remainder. So this is third. I did synthetic once, so now it's a squared. So everybody go 2x to the second plus 5x minus 3. And since I'm looking for zeros, I'm going to set it equal to 0. Now, if this factors, that's sweet, right? If it doesn't factor, then what am I going to do to solve that, everybody? Quadratic formula. Yes, this factors. So it goes to 2x and a plain x. The 3 is going to go to a 3 and a 1. Signs are different. Biggest is a positive, so it looks like that. So I have another solution of 1/2, another solution of -3, and that solution of 1. So I need to make sure I highlight that, right? My others on this example will be none. Now, it's not going to look like that. It's not going to be that easy. They won't all factor, okay? What would constitute an other 0, okay? If you have an I or if you have a square root. So basically, if it doesn't factor and you have to use the quadratic formula, then that's where that's going to go, okay? Okay, here we go with question 7. Find all the possibles. Your constant is a 4. What goes into 4? 1 and 2 and 4. And those go on the top. One mistake that people make is they put it upside down. The constants go on the top. The leading coefficient is a 2. What goes into 2? 1 and 2. Please don't write it like that. You won't get any credit. Even if you put a plus or minus with parentheses, you still won't get credit. So let's go 1 over 1. That's a 1. 1 over 2. That's 1/2. Now change the top number to a 2. 2 over 1 is a 2. And then 2 over 2 is a 1, but I already have a 1 listed, so I don't have to worry about that. Now I'm going to 4. 4 over 1 is a 4, and 4 over 2 is a 2, and I've already got that. So I'm just going to add my plus or minus and my parentheses, and that's what I'm going to highlight. Okay, now I want to try to avoid that fraction if I can. Okay, so everybody go 1 store enter. And then go 2 membar enter, raise it to the third, plus membar enter x squared, minus 9 membar enter, plus 4 enter, and 1 does not work. Why doesn't it work? Because I got a -2, and if it worked, I would have gotten a 0. Let's do a -1. The next ones are so easy. You don't have to keep putting that equation in. You just go -1, store, enter, up, enter. Didn't work. I got a 12. I'm going to skip the 1/2. I'm going to go 2 store enter, up, enter. Doesn't work. -2 store enter, up, enter. I got a 10. It doesn't work. 4 store enter, up, enter. Didn't work. -4 store enter, up, enter. Doesn't work. So now I'm forced to deal with the fractions. Okay. So 1/2 is 0.5. So I'm going to go 0.5 store enter, up, enter, and I've got it, okay? So I know I have a solution of x equals 1/2. I know when I do synthetic, I better get no remainder, okay? So I'm going to put my 1/2 right here. My exponents are 3, 2, 1 constant, so I'm good. So 2, 1, -9, and 4, draw my line. 2 comes down. Don't be afraid of multiplying by half. If you really wanted to, you could go on your calculator 2 times 0.5. But multiplying by half is the same thing as dividing by what? 2. So you just go 2 divided by 2 is 1. That's easy. 1 plus 1 is 2. 2 divided by 2 is 1. A -9 and 1 is -8. -8 divided by 2 is -4. I'm feeling very confident. Okay, that's a nice little, I like that. So somebody go, it means, yeah, I'm good. I'm doing it right. Okay, so we did thirds. Now we're down to second. So everybody go 2x to the second plus 2x minus 8, set it equal to 0. What would you do right now? Take out a 2. Do you have to take out a 2? You do not, because we're solving. But it's definitely easier for you if you take out a 2. So then you have x to second plus x minus 4 equals 0. Does that inside the parentheses stuff, does it factor? No. 4 and 1, 2 and 2, neither one of them subtract to give me 1. So I know it doesn't factor. So I'm going to come down here and I'm going to go x to the second plus x minus 4 equals 0. You guys don't use 2x a second plus 2x minus 8. Remember we had this discussion very, very quickly at the end of a lesson. If I use a quadratic formula on those numbers and use quadratic formula on those numbers, the answer will be identical. Which one's going to be easier? The smaller number. So always go with the smaller numbers. Who says I understand that? Okay, good. Okay, so everybody go x equals -1 plus or minus the square root of 1 squared, which is 1, minus 4 times 1 times -4 all over 2 times 1, which is a 2. Now freeze and listen, this is important as well. Do I have permission from whoever wrote this problem to take my calculator and punch in 20 buttons and just put that in? And I see head shaking no. What's the permission that I don't have? If I did have permission, honey, what would it say? Decimal. Yeah, round. Doesn't give me permission, so I can't. If you do that, your answer is no longer exact and they're not going to give you the credit. Okay, so see this right here? People mess up on that all the time. Like literally 30% of the time, people get that number wrong. I don't get it because it's like multiplying and adding, which you guys are very good at. So I wouldn't even risk it. I would put that in my calculator. So grab your calculator and let's go 1 minus 4 parenthesis, -4, close it, enter, and I got 17. So I have x equals -1 plus or minus the square root of 17 all over 2. Does the 17 break down any further? No. Is there anything I can do? No. So these are my others. Now I have this problem, you guys, that happens often. See number 2? If this wasn't highlighted, I just highlighted it because we were like talking about it. But if this right here wasn't highlighted and if that wasn't highlighted, I don't really even know what your answer is. And a lot of times people won't even put this down. They'll just do a bunch of work and they never say, yay, here are my rational zeros. So please don't do that. Make sure that you go x equals 1/2 and you highlight it and that's it. Okay, we're not done with this example. Grab your calculator. Your midterm is going to be 8 times more important than the quiz you're taking next time. It's twice as important as the only test. Okay, so it's big. It's big, big, big. It's the second biggest thing you're going to do in this class. The only thing that's bigger is going to be the what? The final. It's just a little bit bigger. Okay, so let's check this thing. Take your pencil and I want you to add parentheses right there. Please don't think, oh yeah, I need to check, but it's going to take a ton of time. It's not going to take a ton of time. I'm fast on the calculator, but I can check this thing for sure in less than a minute. Okay, I'm going to go slow right now because we're just learning. But you go parenthesis, -1 plus second x squared 17. Look at your calculator screen and tell me how many closed parentheses I need right there. 2. 1 for the root and 1 for the top, right? Then go divide 2, store, enter. Now, I already have that in my calculator. I needed it to test all those, like the 1/2, right? So go up, up, up until you get on top of that equation again. Hit enter, and I just checked it. Okay, now let's check the negative. Watch how easy this is. Hit up until you're on top of the root that you put in. Go to the right until you're on top of the plus. Make it a negative. Hit enter. Then hit up until you're on top of the equation again. Hit enter. I got it right. I can walk away knowing without a doubt I got every single point on that question. The midterm is worth 150 points, I think. And every question is like, I know the math doesn't make sense, but it's around 12. Around 12 points per on the big guys like that. Okay, here we go with question 8. Possibles. What goes into 16? 1, 2, 4, 8, and 16. What goes in front of the 1? Just a 1. If I put a 1 underneath those numbers, did I change anything? No. So I don't even need to worry about that. I'm just going to add parentheses and put my plus or minus. If somebody asked you to factor this thing, guys, look at that. We can't factor that. It's too big. So this process of finding these solutions helps us to start solving it, which then helps us to start factoring it, which then helps us to start solving it. Okay, everybody go 1 store, enter. Membar, enter, raise it to the 5th. Minus 5, membar, enter, raise it to the 4th. Plus 12, membar, enter, raise it to the 3rd. Minus 24, membar, enter, x squared. Plus 32, membar, enter, minus 16, enter. I never have to put that guy back in. I'll just keep recalling it, right? And it worked. So I'm going to set myself up so I don't make a mistake. And I'm going to write right there, x equals 1. And then I'm going to add things to it. Okay, so I'm going to make it longer just in case there are more. Okay, so everybody put a 1. Look at your exponents. 5, 4, 3, 2, 1, constant. I'm not missing anything. So my numbers are 1, negative 5, 12, negative 24, 32, and negative 16. Draw your line. What better happened right here, everybody? No remainder, right? 1 comes down. 1 times 1 is 1. Negative 5 and 1's a negative 4. Times 1's a negative 4. 12 subtract 4 is 8. 8 times 1 is 8. Negative 24 and 8's a negative 16. Times 1's a negative 16. 32 and a negative 16 is 16. Times 1 is 16. No remainder. Okay, now everybody freeze. I am going to say some things right here in the next 3 minutes that are a little difficult to understand, so I want you to listen. Okay, here's one thing. If that's a 5th, and I did it once, don't write this down. X to the 4th minus 4x to the 3rd plus 8x to the 2nd minus 16x plus 16. Do I know how to factor that? I don't. So I don't have it broken down small enough. If you can take it down to a squared, we can definitely deal with that. Even sometimes, guys, if you can take it to a 3rd, we can deal with that. And that's what I'm going to show you in just a second. That's a little confusing. So what do? Keep looking. Okay, let's try negative 1. Everybody go negative 1, store, enter, up, enter, doesn't work. 2, store, enter, up, enter, and it works. So now I'm going to put comma 2. Don't start over. Some people will do this and do a 2 and then go 1, negative 5, 12, blah, blah, blah. You're not breaking it down if you do that. You're starting over. And I'm trying to get this guy smaller. So this 2 goes here. And now I'm going to do synthetic again. So the 1 comes down. 1 times 2 is 2. I better not get a remainder. Negative 4 and positive 2 is a negative 2. Times 2 is a negative 4. 8 minus 4 is 4. 4 times 2 is an 8. A negative 16 and 8 is negative 8. Times 2 is a negative 16. And I have no remainder. Okay. This did not go great, period 2. So I'm going to see if I can do a better job. This is now an x to the 3rd. Sometimes you can factor an x to the 3rd. Everybody watch. This is confusing, so watch. See these two numbers, 1 and 2? See those two numbers, 4 and 8. Pair those up. Which ones are smaller? The 1 and the 2. Can I take a number out of 4 and negative 8 to turn those numbers into 1 and negative 2? Can I pull something out to make them turn into those numbers? I can. If I take out a 4, then I have a 1 and a negative 2. Who says I followed what you just said? That little test tells me that that will factor. So I know right now that this guy's going to factor with that little test. If I want to keep hunting, I can. But what if I keep hunting and I never find anything? And I don't find it because there aren't any more rationals. So you have to know that how to deal with that, okay? I'm not going to answer. Okay, so I know it's going to factor. So that's a 5th, and I did long division twice. So 5 minus 3 is a 2. 5 minus 2 is a 3. So everybody go x to the 3rd minus 2x to the 2nd plus 4x minus 8. and set it equal to 0 because I'm trying to solve. Okay? All right, look at the x to the third. It's going to go to an x to the second and an x to the first. The order in which you write those two things, x to second, x to first, doesn't matter. Okay? Now watch this. Whatever goes here is going to be multiplied by the x to the second. I want a negative 2x to the second. So that's going to have to be a negative 2. I want a 4x. Whatever goes here gets multiplied by the x. So that's going to have to be a plus 4. The only other thing I check before I say, yay, I just factored it, is I always check that that negative 8 works out. So is it true that a positive 4 times a negative 2 is a negative 8? Yes, so I just factored it correctly. Okay, all right, so the x minus 2 is rational. It gives me a 2, and I've already got it listed. Okay, so I don't know why this thing sometimes won't erase. Anyway, so this guy's good. Now I've got that x to the second plus 4. So everybody go x to the second plus 4 equals 0. If I wanted to, I could use the quadratic formula. I would never use the quadratic formula on this. Never. Because I can just square root my way out. If there's no x to the first, you can just get it over and square root it. Way easier than quadratic formula. So this is x to the second equals negative 4. Then I square root it. You guys, if you're the one that took the square root, what has to go in front of the square root? Plus or minus. Tell me what the square root of a negative 4 is. 2i. Okay? Do you think I can check imaginary solutions? Can I plug those back in? No. I don't have an imaginary button on my calculator. Okay? There's my answer and I'm done. And now I'm confused. Now I'm confused. Because I have an x to the 5th, which means I'm supposed to have 5 solutions, and I've got 1, 2, 3, 4. I'm supposed to have 5. I didn't do anything wrong. Where's my 5th? Where did it go? Talk to me.
Oh, well, we got the 2 from synthetic division, and then we also got another 2 from that.
Beautiful. And you said that so well. So you don't have to ever graph this, but if we did at that 2, when it comes up to it, tell me what it would do, guys. It would bounce because it's a solution twice. Good. Was that your comment, or can I?
I'm just gonna ask, like, how do you know to stop it, like, with the rational zeros? How do you know addition 1 and 2? Like, how do you know it's not like a 4 and 8 and 6?
Because remember, I stored the 1 and 2 in, plugged them in, and when I plugged them in, I got a 0. So I know it's a solution.
Try that one.
Yeah.
Say it again.
Well, so then wouldn't you try the 4, the 8, and the 16 to see if that got 0 as well?
Well, I knew I had broken it down small enough. So see these numbers right here? That little test I showed you? I don't have to keep hunting because I know I can factor it. And if I keep hunting, I would have kept hunting and I never would have found another one because 4, 8, 16, and they're in positives and negatives, none of them worked. So I would have wasted my time. So once I get to a point that I know I can deal with it, I can stop synthetic. Does that make sense? Okay, good question, buddy. Okay, 9, 10, and 11. So we only have like 3 minutes. Today is, oh, you guys are my period 6, never mind. I don't think that these are ever going to show up. I almost deleted them this summer. That's how sure I think that I am that they're not going to show up. But then I'm like, you know what? I got to cover all my bases. And what if they show up? So I'm going to do these in 3 minutes. It's going to be fast math. Okay. Okay. Show that there's a 0 between 2 and 3. So look what you do. You put in a 2. You put in a 3. Okay. So I'm just going to tell you what these are. I'm just plugging 2 into the equation. And when I do, I get a negative 1, I think. Negative 1, yeah. Now I'm going to do a 3. When I do 3, I get a 16. Okay? Look at the picture. Positive 2, negative 1 is right there. Positive 3, 16 is up there. If I have to connect those dots to draw my graph, it has to cross the x-axis in between, so therefore it has to have a solution. So if one of the signs is a positive and one is a negative, than it does cross the axis in between, okay? So here's what I'm going to say. F of 2 equals -1. And f of 3 is equal to 16. So I'm going to say f of x must cross the x-axis between
students, the college essay writing workshop
2
will be held
and
today in the
3.
choir room, 8 to
Okay.
12 during
I think I can
tutorials.
finish
After
10 and 11 literally in like a minute and a half, so I'm going for it. If you have to leave, then leave, but I want to record this, okay? Okay, x plus 1. Set it equal to 0, -1. Look at your exponents. If you're leaving, just be quiet, okay? 3, 2, 1, constant. What's in front? 1. What's in front of the x squared? -k. What's in front of the x? 2k. What's my constant? -1. Don't worry about the case, just roll with it. Bring down the 1. 1 times -1 is -1. I can't combine a -k and a -1, so I'm just going to write it as -k minus 1. Multiply it by a -1, and I get k plus 1. Both signs changed. 2k plus 3 plus 1k is a 3k plus 1. Multiply by a -1, change the signs, combine those, I get a -3k minus 2. That's my remainder, and this is supposed to be a factor. Well, if it's a factor, then the remainder is, tell me. If it's a factor, the remainder is what? Talk to me. 0. Yeah. Move your 2 over, -3k equals 2, divide, k equals -2/3, done. Okay, I'm going to do the next one. If you have to leave, feel free. X minus 1, set it equal to 0, 1. Exponents 3, 2, 1, constant, I'm not missing anything. So I go 2, -3k, k, -2. Bring down the 2. 2 times 1 is 2. -3k plus 2 is -3k plus 2. Times it by 1, -3k plus 2. K minus 3k plus 2 is -2k plus 2. Times by 1, -2k plus 2. 2 and -2 cancel out. I get a -2k. That's my remainder, and the remainder is supposed to be 3. So now I'm just going to go -2k equals 3, divide, I get k equals -3 over 2, done. Okay? Who said that was really fast, but I followed it? Yeah. If you feel like you didn't, just